Hi, hello, good morning. I'm Kavya, Assistant Professor from Samram Institute of Technology. Today, we'll learn how to solve a dump truck problem in system simulation modeling. Now, we have a dump truck problem which is having 6 dump trucks used for a haul coal from an entrance of small mile to a rail load. Here, each trucks are being loaded one after the other, where both the loader and a scale have a first come first serve waiting line for a trucks. After being weighed, a truck begins a travel time and then afterwards return to a loader queue. Here we have certain system events where LQ of T represents the number of trucks in a loader queue. LQ of T represents loader queue. Then L of T represents the number of trucks that is being loaded. Then WQ of T, which represents a weighing queue. WQ represents a weighing queue. Then W of T, which represents a number of trucks that is being weighed one after the other. Then BL, the busy time of both the loader from time 0 to time T. Then BS, the total busy time of the scale from 0 to time T. Next we'll learn about what is event notices, where dump truck problem have certain event notices. In that there are 3 kinds of event notices we will learn here. First one is a ALQ, which ALQ represents the arrival at loader queue. Arrival at loader queue, where T represents the time and DTI represents the truck and I represents the truck number, which either a truck 1, 2 or 3. So the ALQ represents the arrival loader queue. Next EL which represents the ends loading at time T. EL represents the ends loading where T represents the time and DTI which represents the truck and I represents the truck number. Next event notice is EW, ends weighing. The dump truck I ends weighing EW at time T and DTI represents a truck and I represents a truck number. This is a main basics of how to solve a dump truck problem, the system states and event notices. Next we'll learn how my dump truck problem works. Here I have a small diagram for my dump truck problem. Here I have a loading queue, loading, weighing queue, weighing or scale and traveling. This is a basic diagram to solve my dump truck problem. And here I have my list of loading time values, weighing time, travel time. The loading time has 10, 5, 5, 10, 15, 10, 10 and weighing time has 12, 12, 12, 16, 12 and 16 and travel time has 60, 100, 40, 40 and 80. These are the activities are done in my dump truck problem. Next we'll go to another diagram which solves more easily for dump truck. Here I have my loading trucks. There are usually 6 trucks I am using in my dump truck. Initially the truck 1 which is moved to my scale by taking its loading value. Next there are 2 loading points in my loader. The first one represents my first loading point and the second represents a second loading point, where LQ of T represents the loading queue, where we can see the many trucks are being waiting in my loading queue for loading. The truck DT2, DT3, DT4, DT5 and DT6. Whereas in L of T, where trucks are being loaded, where WQ of T, after loading in my L of T, the trucks will move to my weighing queue. After the truck has been filled in my weighing queue, that will move to a weighing scale where the truck is to be weighed. After weighing is completed, it will move to a ALQ for traveling. Arrival at loader queue process. This is a basic process of my dump truck problem. Next we'll see the next steps. This is my step 1 process. Here, as I told before, the truck DT1 which is in my weighing scale, and 2 of my loading points, as I told, the truck 1 and truck 2. These 2 are empty. So I am loading them here. The first I am loading DT2. In next loading point 2 I am loading my DT3. Then remaining trucks are DT4, DT5 and DT6. Now please make a note of it. The clock and the busy service are having same value till the end. The clock time and busy service are having same value till end. Now we'll see how the process goes. Initially my time is 0, clock time is 0. Now I am calculating LQ of T. How many trucks are there in my loader queue? LQ of T represents my loader queue. There are 3 trucks in my LQ of T. DT4, DT5 and DT6. So LQ of T value is 3. Now L of T value is how many trucks are being loaded in my loading. There are 2 trucks are being loaded in my L of T. So DT2 and DT3. So my value of L of T is DT2. Next we'll see WQ of T, the weighing queue. None of the trucks are being moved to my weighing queue. So my value of my weighing queue WQ of T is equal to 0. Then next W of T, that how many trucks are being loaded? Only 1 truck that is being loaded in my WQ of T. W of T equal to 1. Next we'll see BL of value, the busy line equal to 0. Initially we have taken a clock time 0. So my BL value is also 0 and busy service is also 0. As I told before, the clock time and my busy time is having same values till the end. Then next I have to write my feature event list. How I am going to write my feature event list? There are 3 trucks, DT1, DT2 and DT3. First I will take my DT1 value which is in weighing time, So you see the value in my weighing time, the value is 12. So my EW value is 12. Next DT2, the truck DT2, it is comes under my loading. We come to a loading time value. The first loading time value is 10. So EL is 10. Then next my DT3. The DT3, the next value is 5. The loading time of the second loading is 5. So my EL value equal to 5. Now we will write a future event list EW, 12, DT1. As the process goes, EW, T represents the time is 12 and DTI which represents a truck. Then next after DT1 I have my DT2. The DT2 is EL, 10, DT2. Next is DT3, EL, 5, DT3. After writing my feature event list, I have to arrange it in my order from minimum value to a maximum value. Here my minimum value is 5. I am taking that value is my first value. I have to arrange from minimum to maximum. So the EL, 5, DT3. Next I have my DT2. Next I have my DT1. because my first least value is 5, second least value is 10, next is my 12. So next we'll proceed to a second step of my dump truck problem. In my second step, now the DT1 is still in my weighing queue, and here in previous step the minimum value which I have taken is 5. The same minimum value will take for the further step, the clock time equal to 5. The previous minimum value is taken as my clock time of next process. The previous value was my 5, so I am taking that value as clock time for my step 2. The clock time is 5. Now what happens? The DT3, it has been loaded in my previous step 1. After loading process completes, it has to move to a weighing queue because it has a least time value. It has 5 least time, so it has been moved to a weighing queue. Now when the DT3 moves to a weighing queue, this second loading point which will be left empty, so it will be filled from a previous loading queue truck. The previous loader was DT3. Now DT3 is moved to my weighing queue, so DT4 will occupy the loading second point. Now after that, my EW value will not be changed because it is having a maximum value of 12. Still the 5 has to process, then 10, then 12. Now the DT2 value will also not change. Then now I have to calculate my nth loading value. How we are calculating n loading for a second process? In previous process there was only one value, so we have taken a first value. Now I have to calculate n loading for my DT4. The formula to calculate my n loading is previous time plus present time. The previous time is nothing but the previous value of my DT3 was 5. Now previous time was 5 and my present time which we will see in my table, loading time, the third value is 5. This is your DT2 value is 10, the DT3 value is 5, the DT4 value is again 5. So previous time plus present time, 5 plus 5 equal to 10. Now we'll calculate LQ of T. In LQ of T equal to 2 means there are 2 trucks that are being loaded in my loading queue. LQ of T equal to 2. Then L of T equal to 2 because there are 2 trucks that is being loaded. One is DT2 and my DT4. Then in WQ of T there are 1 truck that is being there in my weighing queue. So WQ of T equal to 1. Then WT equal to 1 means there is 1 truck that is being weighed. Now busy service and your clock time is same, so 5. Now busy line equal to 10. How to calculate my busy line value? The busy line, there is a formula here, BL equal to clock time minus busy service. The busy service here you will take a previous process value, means the step 1 value of BS into L of T, the step 1 value of L of T plus BL, the step 1 value of your BL. So the current time is 5. Then next previous BS value was 0 into L of T. L of T of previous one was 2 plus BL value was 0 equal to 10. So BL value equal to 10. The step 1 and step 2 processes completed. Next we will move on to a next process 3. So before moving to my process 3, we have to write a feature event list of my step 2. feature event list was EW equal to 12 of DT1, DT1, EW comma 12 comma DT1, next EL comma 12 comma DT2, then EL comma 10 comma DT4. Now I have to rearrange them from minimum value to a maximum value. So EL comma 10 comma DT2, EL comma 10 comma DT4, EW comma 12 comma DT1. Next we'll go for a step 3. In step 3, after weighing, the truck DT2 has completed its loading. Now it is moving to my WQ of T, because the previous value of my DT2 was 10. That was the least value. So the least value that will be moved to a next process. So the DT2 is moved to my weighing queue. Now in place of DT2 it is left empty. So DT4 is moved. So in DT4 place the DT5 has arrived. Now I have to calculate a loading value. Now in loading value of DT5, the previous value of DT4 was 10 plus next loading time value is after 5, it is 10. So it is 10 plus 10, 20. Now what is the clock time? Clock time of my previous value was, I have to take a least value of a previous process. The least value is 10. 10 EL comma 10 comma DT2. Now my clock time is 10. Next, LQ of T. There is one truck that is in weighing queue. Then L of T, there are two trucks that is being loaded equal to 2. Then WQ of T, there are two trucks that is being weighing in your weighing queue, so equal to 2. Then WT equal to 1 truck that is weighing on your scale. Then BS equal to 10. Now BL equal to 20. How my BL value is calculated? As we saw the formula in a previous step. The 10 is your current time and 5 is your previous BS value into 2 is your previous L of T value and 10 is your previous BL value. After this process, we have to write a feature event list. The feature event list first will come from DT1. The DT1 value is EW, 12, DT1. Next, the truck is DT4. The EL, 10, DT4. The next truck is DT5. The EL, 10 plus 10, 20, DT5. We will arrange that into a minimum value to a maximum value. The minimum value is my 10, the DT4 value. EL, 10, DT4. EW, 12, DT1. Then EL, 20, DT5. Here in this process, my least value is 10. That is DT4 truck value is 10. This 10 we will take as a clock time for step 4 process. Next, this is your step 4 process. Now, the previous least value was 10, that is of DT4. Now, the DT4 has been moved from loading point to a weighing queue. Now, in your weighing queue, there are 3 trucks, DT3, DT2 and DT4. There, in place of DT4, the DT5 has been moved. In place of DT5, the truck DT6 has been arrived. Now, there are clock time is T. Clock time T equal to 10, the previous least value or a minimum value of step 3 process. Now, LQ of T equal to 0 because no trucks are there in your loader queue. Next, L of T equal to 2 because still there are 2 trucks that is being loading. Then WQ of T, there are 3 trucks that are in weighing queue. Then W of T equal to 1, the 1 truck that is there on your weighing scale. Now the BS value equal to 10 because my clock time and my busy service time is same till the end. My BL value is the current time is T minus your previous BS value into L of T value plus your BS value. Its value is 20. Now I have to calculate a loading time for DT6. My previous value of my DT5 was 10. Previous was 20. Then 20 plus my value is 15. It goes according to my formula, the previous time plus present time. The previous time it was 20 and my current time is or a present time is 15. Now EL value is 20 plus 15. Now I am going to write my feature event list for step 4 process. Then EW, 12, DT1. Now the next truck is DT5. EL, 20, DT5. Next is my DT6. EL, 10, 15. DT6. Now I have to rewrite that. The EW, 12, DT1, EL, 20, DT5, EL, 10 plus 15, DT6. 10 was my previous value of your DT5 plus present time 15. So EL, 25, DT6. Now we'll move on to a step 5 process. In my previous step 4 process, my least value was 12. So the current time of my step 5 process is 12. The least value is DT1. So DT1, now it is moved from weighing scale to a traveling process. Means the ALQ, arrive at loader queue process. The DT1 has been started its arrival to a loader queue process because its least value is 12. So it is moved from weighing scale to a traveling time. My current time is 12. Then LQ of T, no trucks are there in my loader queue. Then L of T equal to 2, the 2 trucks that is still loading. So L of T equal to 2. Then WQ of T equal to 2 because there are 2 trucks that they are in my weighing queue, WQ of T. So one truck that is on scale. So WT of T equal to 1. Now my BL value is 24, BS value equal to 12. Then feature event list value. The EL, 20, DT5. Now EL value is DT5. I am going from step by step process. First I am coming to loading part. In my loading part there are 2 trucks. So I will take the first truck, the DT5. So EL, the value of DT5 is 20. The next truck is DT6. Its value is 25. The EL, 25, DT6. Then next I will come to my weighing. EW, in weighing what happens? My previous weighing time was 12. The 12 is my value of DT1. DT1 weighing value was 12 previously. So I have to add my previous time plus present time. The present time of my truck DT3 is, I have to come to my weighing time table. In that the second truck is 12. So previous time was 12 plus 12. Now the truck DT3, it is having EW, 12 plus 12. So it is 24 DT3. Then ALQ. The value of my DT1 was 12 previously plus the ALQ, the first value of arrive to loader queue. That time you have to check your traveling time. The first value of DT1 was 60. So 60 plus D12. 60 plus 12, DT1. 60 is your traveling time value plus 12 is your weighing time value. So traveling time plus weighing time. So the ALQ is 60 plus 12 comma DT1. Now your ALQ comma 72. 60 plus 12 is 72 comma DT1. Now we will write a feature event list in order from minimum to maximum value. So the first minimum value is my 20. That is the value of my truck DT5. EL comma 20 comma DT5. Then EW comma 12 plus 12 comma DT3. The 12 plus 12 is the previous time plus present time of truck DT3. Next is EL comma 25 comma DT6. Next I have to write my ALQ value of DT1. 60 plus 12 DT1, that is ALQ of 72 comma DT1. Now it is arranged from minimum to maximum value. Here the minimum value is 20, that is a value of DT5. As I told before, the minimum previous value, it is taken as a clock time for next process. Now we will move to a step 6. Step 6. Here the previous time was 20 of DT5. So T equal to 20. Then LQ of T, there is no trucks in my loading queue. So LQ of T equal to 0. Then L of T equal to 1. Then WQ of T equal to 3 because there are 3 trucks are being weighing. Then one truck that is being weighed in on your scale. WT equal to 1 and BL equal to 40 and BS equal to 20 because clock time and your BS value is same. The BL value you have to do with your formula, that current time minus previous BS value into L of T plus BL value equal to 40. Now feature event list, here is EW comma 24 comma DT3, EL comma 25 comma DT6, ALQ comma 72 comma DT1. Now there are 3 trucks. One is DT1 that is traveling and DT3 that is on weighing scale, and one truck that is being loading, that is DT6. Now we have arranged into minimum to maximum value. Here my least value is 24. So the T clock time value for next process is 24. This DT truck, now it is moved to my traveling process because previously it has been weighed in my step 6. In step 7, the DT3 value, this is DT3. Now in step 7, the DT3 has been moved from weighing queue to your traveling time or a traveling process. Now in place of DT3, the truck DT2 has been moved to your weighing scale. Now DT3 is moved to a traveling time. Now the clock time is T equal to 24 and LQ of T equal to 0, L of T equal to 1, WQ of T equal to 2, W of T equal to 1, and calculating a busy line equal to 44, BS equal to 24. Now how to calculate a DT3 value? The previous traveling time of DT1 was 72. Now my EL value or a EW value of DT3 was 12. Now I have to come for travel time is 100. So my travel time is 100. Then EW value of DT3 was 12 and this 12 is my previous value of your DT1. The previous DT1 of EW value was 12, the first 12 which represents the EW value of DT1, and the second 12 represents the EW, the nth weighing value of your DT3, the next 100 which represents the travelling time of your DT3. The next EW is 24 plus 12 DT2, then EL 25 comma DT6. Now we will arrange it from minimum to maximum. EL comma 25 comma DT6, EW comma 24 plus 12 comma DT2, ALQ comma 72 comma DT1, ALQ 24 plus 100, then DT3. 12 plus 12 24 plus 100 is your travelling time. Now here my least value is 25, the value of my DT6. Now that is a clock time for my next process, step 8. In my step 8, the DT6 has been moved from loading to your weighing queue process. The DT6 that has been moved from your weighing queue loading to your weighing queue. Now there are 3 trucks that has been in your weighing queue and DT2 that is still on your weighing scale. Now I have to calculate BL value equal to 45 and BS is 25. Now my DT2 value, the previously my DT2 value was 36 because 12 plus 24. The 12 was your previous DT3 value and 24 was your weighing time value. So 12 plus 24, then ALQ of 72 comma DT1. There are 3 trucks. Now the DT1 and DT3 and DT1. Now here my least value is your 36. Now this DT3 will move to your travelling time. Now in step 9, the previous value was 36. The DT2 will be moved to your travelling time. Now the remaining in the place of DT2, the truck DT4 has arrived and there are 2 trucks that is being weighed on your weighing queue. So WQ of T equal to 2, LQ of T equal to 0. So no trucks that are in loader queue, and L of T equal to 0, no trucks that are being loaded, and WT equal to 1, that is 1 truck that is being on your weighing scale. Then BL value equal to 45, BS value equal to 36. Now we will write a feature event list. Then EW of DT4. Then the previous value was my 36. The 36 was my value of your DT3. DT3, the truck 3. The next value is 16. Next value is 16. The 16 that comes in your weighing time, the 4th truck value. So 16, that is 36 plus 16. Then ALQ comma 72 comma DT1. Next the truck DT2, ALQ comma 36 plus 40 DT2, and ALQ comma 124 comma DT3. Now here my least value is 36 plus 16. The value equal to 52. The 36 plus 16 equal to 52. 52 is your least value, the value of truck DT4, and that is a clock time for your next process, the step 10. In my step 10, the truck DT4 has been moved. Now the truck DT5 and truck DT6. DT5 that is still that has come to your weighing scale and DT6 is still on your weighing Q. Then ALQ of DT4 is, ALQ of your DT4 is 52 plus 40. 52 plus 40. 52 was your previous DT3. The present 40 is your present traveling time. Now my EL value, DT5 value. The DT5 value is 52 plus 12. The present time plus previous time. Now we will arrange it in a from minimum value to a maximum value. The EW of 52 plus 12 equal to 64 of DT5 value, and ALQ is 72, DT1, ALQ, 76, DT2. Then ALQ equal to 52 plus 40 DT4, ALQ, 124, DT3. Now the least value in this process is 64. That is a clock time of your next process. Now the step 11. The clock time is 64. That now the truck DT5 has been moved to a traveling time. In place of DT5, the truck DT6 has been arrived. So my DT5 value is 64 plus 80. The 64 was your previous time and 80 is your traveling time. Now EW, 64 plus 16 DT6. 64 was your previous value and 16 is your weighing time value. Now ALQ, 64 plus 80, DT5, that is ALQ value. That ALQ, 72, DT1. Then ALQ, 76, DT2. Then ALQ, 92, DT4. Then ALQ, 124, DT3. Now we'll write in a minimum to maximum value. Now my minimum value is 72. That will be a clock time for your next process. Now we'll move on to a step 12. Now all the trucks has been moved to a traveling process. All the trucks from DT1 to DT6. Now you may think that the process has been completed, but still the loading time value still there, because my loading time has been ended till 15. So still my loading time value is there. So still two more values has been left in my loading time. The first truck which has been arrived for your traveling process was truck DT1. So the same truck will return to your loading queue. What is the process? After finishing its traveling time, it has to come to the loader queue, arrive at loader queue process. Now the two more values that are still remaining, as we see before, the 10 and 10, there are two values. So the truck DT1 again it come for loading. So the time is T equal to 72 clock time. Then LQ of T equal to 0, because no trucks that are in your loader queue, and one truck that is being loaded, that is DT1, and WQ of T, that no trucks that are in your weighing queue, and DT6, that one truck that is still on your weighing scale. So BL value equal to 45 and BS equal to 72. Here we are not calculating any BL value. It is of same as of your previous step. Now the feature event list ALQ, 76, DT2, EW, 80, DT6. EL value was 72. 72 is your ALQ value of DT1. 72 is ALQ value of your truck dt1. So EL comma 72 plus 10. The 10 is your loading time value. So 72 plus 10 comma dt1. Then ALQ comma 92 comma dt4, ALQ comma 124 comma dt3, ALQ comma 144 comma dt5. This is a process. Now here the least value is 76. So this will be my clock time for a next process. My next process is step 13. Step 13. In my step 13, in previous step, the one truck that has come for loading. Then the one more truck that has been left empty. For this place, the next truck was in my traveling process was DT2. This truck DT1 has come for my loading and they left out the second loading point. In that place, the DT2 process will come. Now we will calculate the DT2 value. The EL comma the DT2 value was 76. 76 was my ALQ value. 76 was my ALQ value of your DT2. So 76 plus 10. 10 is my loading time. 76 plus 10. So EW comma 80 comma DT6. The DT2 value will be 76 plus 10. 10 is your loading time and this is your ALQ value. So EL comma 76 plus 10 DT2. Then ALQ comma 92 comma DT4. ALQ comma 124 comma DT3. ALQ comma 144 comma DT5. Now all the timing values has been completed. The loading time, weighing time and travel time. All the process has been completed for your dump truck problem. Now we have to calculate our average loader utilization. 49 by 2 divided by 76, it gives 0.32 and average scale utilization equal to 76 by 76, that is 1. This is a process of your dump truck problem. Thanks for watching my video. Thank you.